So you got coterminal angles in your notes now. Now, a little bit of detail about this that we can get out of it. First of all, the 300 degrees and our negative 60 degrees. How far apart are they? Yep. They are 360 degrees apart. Anytime two angles are 360 degrees apart, they will be considered coterminal. Terminal just means ending. Co means together, so they end at the same place. So if they're 360 degrees apart, they're ending at the same place on the circle. We've just gone around an extra time. Now, certainly if you go around 360, we can of course go around another 360 as well. So for instance, two angles could be 720 degrees apart. And they would still be coterminal because they're still just ending in the same place. We're going around the circle twice in that case. So that's the idea of coterminal angles. And we're going to practice it here with a couple examples. We're going to go through this first one here together, then I'm going to give you a few minutes to do the other three. So for number one here, we want to figure out what angle is coterminal with 60 degrees. Now we can visualize where 60 degrees is. Now if that's 60, one way I can get a coterminal angle is by going around counterclockwise 360 degrees. So notice that is adding 360 to it. So what is 60 plus 360? Yes, it is 420 degrees. So 420 degrees is also coterminal with 60. Now I could also add 360 to that and still get a coterminal angle. So for instance, 420 plus 360 would give me 780 degrees. That would also be considered coterminal because I just kept going around the circle. Now, in that example, I was going around counterclockwise. But we can also go around the other way as well. So for instance, if I started my 60 and I went around clockwise, that's like subtracting 360. What is 60 minus 360?
60 minus 360 is negative 60.
That'd be negative 300 degrees.
You knew what I was thinking.
And so those are all different ways of getting a coterminal angle. Now in this particular example, you only need to give one of those. Just find one angle that is coterminal. But of course there's many different ways you can choose to get there. So having seen number one done, go ahead and now find coterminal angles for numbers 2, 3, and 4. Do those on your own, then we'll come back together to see how well you're doing with them. Alright, so let's take a look and see what those are going to look like. So for number 2, we start with negative 150 degrees. Now, starting in the negative, almost everybody will tend to add 360 to that. So if you chose to go that route and add 360, you would end up with 210 degrees. But of course, that's not the only way to do it. You could have subtracted 360, for instance. If you did happen to choose that route, that'd be negative 510 degrees. If you chose to subtract, but of course you only need one of those, and there's other options that would work as well. Okay, 225 degrees. So for 225, if we add 360 degrees to that, that would get us 585 degrees. Or if you subtracted, that'd be a negative 135 degrees. Both of those represent actually all three of those even, we could say, represent this same angle here. It's just a matter of how many times around the circle and which direction are we going to get there. But since they all end at the same place, that's why they're called coterminal. Alright, last up, 450 degrees. Yes, you could add 360 to that. If you did that, you'd have 810 degrees. But since it's starting with 450, which is over 360, most people tend to just subtract and choose to subtract in that case. And so if you chose to subtract, you'd end up with 90 degrees. And so notice then, 450 degrees is the same as 90 degrees. Because of that, some implications for why we would want to know this. The sine of 90 degrees is 1. The sine of 450 degrees then would also be 1, because the sine and cosine values are going to be exactly the same for coterminal angles. So it lets us suddenly know every possible angle and its sine and cosine that's related to that original unit circle. This just goes from 0 to 360. All right, so we're going to be graphing cosine now. Now, for graphing cosine, it's a new function type. Normally, when we graph a new function type, we end up making a table of x and y values and then plotting each of those to get an idea about what the graph looks like. You've actually already got the table of values. This table that we are working with throughout the last section is actually a set of x and y values that we can use. In this case, since I'm graphing cosine, I'm just going to look at the cosine values. I don't need to worry about the sine ones. Now, this is the x and y values because the x's are just the angles. My y values are what cosine is. So in plotting these, for instance, this very first point that I have here is 0, 1. So I can then actually plot the point up here at 0, 1. So go ahead and plot that point on your graph, 0, 1. And then I'm just going to keep going through this table to get points. So the next one is going to be 30 degrees and root 3 over 2. But how do we plot root 3 over 2? Well, it'd be useful if we knew what it was as a decimal, right? So we could actually calculate that. We can do the square root of 3 on our calculator and we can divide that number by 2. When you do that, you should be getting about 0.87-ish. And we can do the same thing for the root 2 over 2, because we're going to need that as a decimal. So go ahead and make note there that root 2 over 2 is about 0.71, and root 3 over 2 is about 0.87. And then, now we can go back to plotting our points. Remember where I was working on 30 degrees and root 3 over 2? So I need to figure out where 30 degrees is. So noticing our scale here, 90 degrees is here, and notice that was cut up into 6 sections between 0 and 90. What's 90 divided by 6? It's actually 15. So that means that each one of these hash marks represents 15 degrees. So if I'm going to go to 30 degrees next, that means I'm going to be somewhere there. So that's 2 hash marks over. And I need to go up to 0.87, because it's root 3 over 2. Well, you'll notice that each of the grid lines going up is 0.1. So if I want to get up to 0.87, that means it's going to be right up here just below 0.9. And so go ahead and plot that point. So that's over to 30 degrees, which is 2 hash marks, and then up to 0.87, which is just below the 9th hash mark on the way up. All right, next up, 45 degrees. That's root 2 over 2, so I got to go up 0.71. So I go over 45, which means 3 of the 15, so it's going to be taking me there. And then I got to go up 0.71, so that means go up 7, because each one's 0.1, and then maybe just a tad bit past that last one. So 0.7, and then just up a tiny bit past it. And there we go. All right, next up, it's got to be 60 degrees. Okay, so 60 degrees is a half. Thankfully, we don't have to do any work with messy decimals for that. So we're going to go over to 60, and 60 degrees, it's going to be right there. It's 2/3 of the way to 90. 4 hash marks over, however you want to say it. And then that's going to go up to a half. And you notice that extra little dotted line there at a half, just to make it a little easier to see and find. Okay, next angle is 90. Notice our coordinates there are 90, 0. So I'm going to go over to 90, and I'm going to put a point there at 0. Having done that part, I think you got a pretty good idea about how to get these points plotted. So go ahead and continue plotting each of the individual pairs of points. All right, so then our next point, that's got to be the 120, which is at -1/2. So that means that we go over to 120. Now, that means 2 hash marks over because I'm going over 30 degrees more. And then I go down to negative 1/2, so negative 0.5. So that's where that next point goes. All right, then let's see how you're doing on that next point. So the next one we encounter is the 135 degrees. So that's going to be halfway between 90 and 180. And that one's going to be down 0.71. So I'm going to go down to the 0.7 and go down just a little bit further. And then from there, we're basically just keeping on the same pattern. When you get all the points plotted, this is what you should be looking at. And it starts to give us a pretty good idea about what this graph can actually look like. Now, when we draw the curve in through that, just to help you kind of see the overall picture, this is what that curve ends up doing. But now notice we've only filled in half of the graph. Well, in case you were thinking what was up with the coterminal angle stuff at the start of class, what did that have to do with the graphing? Well, now we're going to connect them up. Because 30 degrees. What do I get if I add 360 to 30? Well, that's going to be, excuse me, 390 degrees, yeah. So that tells me then that if I go over to 390, which is right over here, I should get the exact same cosine value of root 3 over 2. So I can go over and plot that next point at root 3 over 2. Okay, now I'm going to redo the same thing with the 45 here. What do I get if I add 360 to 45? Should get 405 degrees. And 405 degrees then, it's right over here. And so then I can go up to 0.71 there. And then we can repeat the process. Let's go over to the 60 next. So if I go over to 60, if I add 360 to 60, that gives me that 420. We saw that one earlier, in fact. And so if I go over to 420, I should be going up a half. Now something I hope you're noticing here. Isn't it really just repeating the exact same pattern that we saw up here? And because this is going around in a circle and the coterminal angles are just adding 360, really then, this pattern just repeats itself. And the graph after 360 is exactly the same as the graph between 0 and 360. So go ahead and fill in the rest of that graph. Now this happened to be 2 cycles of this graph. The cycles are just like the 0 to 360 part, you know, where it started at the top and ended up back at the top again. So that was 1 cycle. So this was 2 cycles. But of course, if I extended out my graphing grid to the right, I would be able to just keep on continuing the same pattern going to the right. Or I could even extend the graphing grid to the left and continue following the same pattern going to the left as well. So it's just this repeated wave over and over and over again in all directions. So once you get to know this wave, it's going to be just a matter of where do we start in that wave, and then following a pattern that we know. So we're going to practice doing that. Go ahead and write this equation down above your next graphing grid. We're going to do 5 of these other equations. So this is going to be y equals a negative cosine theta. And the theta, again, the theta, it looks like a 0 with a line through it. But all theta is just another variable name. It could also have been called x, but theta is commonly used for angles.
Theta. Okay.
So, we're looking at negative cosine theta.
It sounds like you said
Now, it's going to be the same thing as regular cosine, except what does the negative do to it? The negative reflects it. Yep, it flips it, it reflects it across the x-axis. So like normally our first point was up at 1. Okay, so where's my first point going to be in this case? -1, yeah. Now that means I do need to decide where -1 is here. There's two different ways of doing the graph at this point and putting the one and the negative one on. Some people will just use all of the graphing grid. And in fact, I'll often tend to do that as well, but not on this first lesson. For this first one, I'm actually going to just go by ones. That way, as you're comparing these later, everything will have been done on the same scale, so it'll be a little easier to tell what actually caused the differences rather than the scale being a changing part as well. All right, so we said our first point is normally at it's normally at 1, and in this case it's at -1 because of the negative cosine. So notice in this case then I start at the bottom of the wave. The next point, let's go straight to 90. At 90 degrees, the cosine of 90 is 0. Well, a -0 is still 0. Okay, 180. The cosine of 180 degrees is -1. And since this is negative cosine, that means it's actually going to be at a +1. So at 180, we're going up 1. That's where the top of our wave is. And then at 270, what's the cosine of 270? It is 0. And at 360, the cosine of 360, well, that's got to be the same as the cosine of 0, so it's also -1. So it starts and it ends at the bottom. Now, there's actually a pattern I'll often come back to in remembering this. This one started at the bottom, then it went to the middle, the top, middle, bottom. This same pattern is what repeats itself going forward. So I start at the bottom, and then it's middle, top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom. You could keep plotting those points to fill in as much graph as you were given. It's just a matter of where do you start in that pattern. And in this case, we start at the bottom because of the negative. All right, now before I go in and actually draw my graph in, we could technically draw the graph in just from these points. And in fact, within a few days, that's all you'll need to make your graph. But if we do that now, I tend to end up with stuff that looks like this. That's not what this graph looks like. You'll sometimes hear me say as we go on, I want to see waves, not lightning bolts. It should not be sharp-edged. And so we're going to be looking for something that's a little bit more like this. But in order for you to get used to what that looks like, I want to put on a few more points that you can target. Now, the easiest of those other points to plot are the 1/2s. So let's do those. The cosine of what gives us a half? Well, the first one is 60. And so then I'm going to go over to 60 degrees, which is right here, and I'm going to go down a half. Go ahead and plot that point. And again, I'm going down a half, not up a half here, because of the negative in front of the cosine. All right, when's the next time we hit a 1/2 for cosine? It's at 120. So I'm going to go over to 120, and my -1/2 becomes a +1/2. All right, when's the next time I hit 1/2 for cosine?
240.
Yep, 240 degrees. So that is just short of 270. It's over here. So I'm going to put a 1/2 there. And then the last one out of our normal unit circle there is at 300. Yep. And so that's going to be down at -1/2. Once you plotted those, you're going to be able to be pretty accurate with drawing your curve in. So go ahead now and draw the curve in that goes through those points. As you're first learning to draw these in, it can be a little bit tricky to get that curve looking good. I know for me, when I was first learning to draw them, I'd kind of sketch it in super light in pencil until I finally felt like it was about the right way, and then I'd go over it to actually make the curve. But that's what worked for me. Find the way that works for you. I also find oftentimes that turning the paper to a comfortable angle can also help you make a smoother curve. All right. Now that we got that one, we can go on to the next. So we're now going to be graphing y equals 2 times cosine theta. And again, make sure you write this above your next graphing grid. All right, so for this one, what does the 2 actually do to the graph? How do we describe that transformation? Yep. It is a vertical stretch by a factor of 2. The fact that it's a stretch is a big distinction here. It means I'm multiplying all my values by 2. So normally then, I would start at 1. I'm not going to start at 1 though. What am I going to start at? 2. Because I'm doubling whatever my normal value is. So my first point, 0, 1, becomes 0, 2. All right, now let's go over to 90. The cosine of 90 is 0. What's 2 times 0? 0. So you notice the middle, it didn't move because it's normally at 0. Okay, at 180, I'm normally down 1. In this case, it's going to be over 180 and down 2. Now the beautiful part is we now basically know where the top, the middle, and the bottom are. And so we can now go ahead and fill in the rest just by following the pattern. Top, middle, bottom. Next up is middle, so it goes at the same height as the other middle. And next up is top, so it goes at the height of the other top. Now again, here pretty soon, this will be enough for you to draw the curve in through, but since we're still getting it down, I do want to plot a few other points. I'm going to plot those 1/2. So, 60 degrees, the cosine of 60 is 1/2. In this case, though, I'm not going to go up 1/2. I'm going to go up how far? 1. Because remember, I'm multiplying the heights by 2. 1/2 times 2 is 1. So, I can go over to 60 and plot it up 1. The next time it's 1/2 is at 120. So in that case, we're going to go down 1 there. And then 240 and 300 as well. Once you plotted those, you should have enough to make sure that you're going to get a decently smooth curve. So go ahead and draw the curve in from there. Next up, we're going to be graphing with a shift in here. So write this equation down above the next graphing grid. Y equals cosine theta plus 1. Now the plus 1, as we saw in the past, it would be moving it up 1. And with cosine, that's no different. It's still going to be moving the whole graph up 1. But when we're dealing with cosine here, that can get a little bit tricky to keep track of every point being moved up 1, because we're plotting many more individual points. It's not like plot 1 and then everything else relative to it as much. So I'm going to show you a little trick here that works with something as simple as this, but it actually works great as they get more and more complicated. And that is to start by drawing in 3 dotted lines. The first one I want to draw in is the midline. The midline is normally here at 0. Where's it going to be in this case? It's going to be up 1, yep. So start by drawing in a dotted line, up 1. And yes, it does need to be dotted. If you made it solid, you'd be saying this is actually part of the graph, part of the wave. Dotted means it's just a guide. Kind of like we did with asymptotes, but it's not an asymptote, it's just a guide. All right, so I know the midline is up at 1. Now I need to put in 2 other dotted lines, one above it and one below it to show where the top and bottom are. How far up and down are we going in this one from the midline?
1.
It is 1. Because there's no number written in front of the cosine. That means it's 1 cosine. And so put another dotted line that's up 1 from the midline. And now the dotted line that is down 1 from the midline. And so when you use this, always draw on all 3. Just drawing in one of them isn't quite nearly so helpful. But draw on all 3 dotted lines, because once we do so, we can actually just jump into our pattern. This is regular cosine. It's not been flipped upside down. So where does it start? Does it start at the top, the middle, or the bottom?
Top.
It does start at the top, just like your parent function, that big one above all these. Now, before I start plotting the points, let's see if you got the idea of that pattern down. From the top, where do we go next? Top, middle, or bottom? Middle. So top, middle, bottom, then middle, and then top. Once you start at the top, if you're at the top already, obviously you must be heading towards the bottom. But you can't get to the bottom without going through the middle. So that's why it's top, middle, bottom, And then once you're at the bottom, you're trying to get to the top. And so then again, you have to go through the middle in order to get to the top. All right, let's plot some points. So the way that this makes our lives easier is when we have those dotted lines, I just put my first point on the top line. Then I put the next point. We know it's supposed to be at middle, so I put it on the midline. The next one says it's at the bottom, so I put it on the bottom line. And then back to the middle, and then back to the top. So by drawing in those dotted lines, it makes that a lot easier. Now this is a fairly simple, straightforward one, but you're going to see as we start including more transformations all at once, it's super helpful to have all that drawn in. And then once again, I do want to plot in a few more points here just so we can be a little extra accurate. The cosine of 60 is normally a half, so that means I'm going to go up halfway from my midline to my top. And then 120, we can also put it, and then 240 and 300 will then give you enough points where you can draw in your curve fairly smoothly and fairly accurately. So go ahead and now draw it in. All right, and then if you are having any trouble drawing the curve in nice and neat, I'll show you a little trick that can help, especially at first on those. You know it's going to be flattening out kind of along the top and bottom. I should use a different color there. So it's kind of flattening out there, it's getting flatter there, and it's getting flatter over here. You can draw in those fairly flat sections there towards the top and the bottom, and then connect them, and it'll actually get you a nice start on seeing how those curves can look. So that could be a nice starting point if you're still working on getting those curves in. All right, next one, second to the last problem we're going to graph here together. Y equals cosine theta minus 90. Write down that equation above your next graphing grid. All right, so we got our theta minus 90. The 90 is in with theta. Just like it's in with x, that means it moves it over. Which way does the minus 90 move it? Does it move it left or right? Minus moves right. Plus goes left. This is that annoying one that's always backwards in the way you think it probably should have been. So minus 90 means go to the right. So my first point is no longer going to be here at 0, 1. But I am still going to start at the top. Instead, the top is actually over here at 90. So that's going to be the first point I plot. I start up at the top at 90. Having done that, I know that's the top. So as I go to the right, I can just jump into my pattern here. It goes top, middle, bottom, middle, and that's all the grid I have. So the midline, remember, it did not move. The bottom, it's still down 1. So I can fill in those points. Now, so far, that tells me this much of the graph. But what is happening between 0 and 90? Middle. Yep, at 0, it's got to go back to the middle. Because if I'm at the top, the next thing in the pattern, basically it's like I'm reading the pattern from right to left. Middle, bottom, middle, top, middle would be next in that pattern. And so then, that is what your graph should be looking like for cosine of theta minus 90. All right, so I just gave you 4 different graphs with each of the 4 different transformations applied to them. Now it's time to put them all together. So please write down this equation above your next graphing grid. This is the last one we're going to do together. And then take a minute and actually start making the graph. And then we'll come back together and see how well you're doing at it. All right, so let's see how well you're doing with this now. So first thing I want to do is I want to put on the midline. Where is the midline in this problem? It is at 1. Because this one over here, that's the one that moves it. That's what moves the midline. So first thing I'm going to do, draw a dotted line across at 1. Then I need to draw on the other 2 dotted lines. From that midline, how far up and down am I going to go here? It's always the number multiplied. So it tells me it's going to be up and down 2. So from my midline, I go up 2, and then I go down 2. All right, so far now, I've used the up 1 and I've used the 2, which is the vertical stretch. I've not yet used the 90 or the negative. So what's the negative going to do to my first point? Yep, it's going to move that first point to the bottom. So I'm going to start the bottom, and then that bottom point is going to be right 90. And so that means that I know that that point will be at the bottom. And so I can go ahead and plot that on the bottom dotted line. A problem like this where you got so much going on, it's definitely essential to draw these dotted lines in. They help so much. Now, if I'm at the bottom, I jump into my pattern. Next up is middle, top, and middle. And then continue the pattern to the left. If I'm at the bottom, the next thing is the middle. All right, and then once you've drawn in the main points, we can put in the 1/2 as well to improve our aim and make our curve look a little bit nicer. And then go ahead and draw the curve that goes through those points. And so then this is what our final graph should come out looking like. Once you have that, then you're going to be able to handle pretty much any of the cosine graphs that you see.